While calculations at ligand coordinates cannot produce stabilization energies, calculations at coordinates other than the ligand can. In the 4-STD example, there are two crystallographic waters closest to the ligand whose coordinates can be used to perform a SZMAP stabilization calculation. In this tutorial, you will calculate SZMAP stabilization values at the two crystallographic waters coordinates. After completing this tutorial, you will be able to set up a SZMAP stabilization calculation at coordinates, calculate stabilization grids at specified coordinates. To use the two crystallographic waters closest to the ligand, you need to split them from the original 4std.pdb file. On Linux or OS X, you can separate the water molecules by using the egrep utility program, as shown on this slide. You can also split the waters using Vida or a text editor. Next, you then run SZMAP with the -add coords flag and the file containing the two waters as the command line argument. So here's a demo run. First, make sure you have all the required input files. List files in the current working directory as shown. You can see that there's a file called 4std_selected_waters.pdb. This is the file containing the two waters we are interested in. If you wish, you can view the contents of the file. The water molecules are from chain A, and they are HOH A 187 and HOH A 190. Next, type in the full SZMAP command and the command line arguments. Do not forget to enter the prefix. In this example, you will use 4std_wat_coords as the prefix. This type of calculation is very fast, and from the information on the screen, you can see that stabilization calculations were done at the 2 points corresponding to the two crystallographic waters. And now, if you list the files in the current working directory, you will note that 4 files were created successfully. This means that you are now ready to examine the results in Vida. In summary, you learned how to perform a stabilization calculation at coordinates other than the ligand. It is important to note that the main difference between this calculation and the one done using ligand atoms is that this calculation will provide water stabilization information, whereas the ligand position calculation allows you to glean some information about the binding site.